Hi, my name is Michael, and I'm going to be walking through the Introduction to Python. Python is an interpreted language. Unlike some of the other programming languages like C or Visual Basic, well, Visual Basic could be considered either, in that whenever you code in a regular programming language, you compile your code and it creates an executable that you can run. An interpreted language is a program that requires another program in order to interpret it to perform the functions at runtime. The best example of one of those is Java. Java requires a runtime engine in order to be able to operate Java code. Python is very much the same way and follows the same general principles in that the advantage is the code's portable. Interpreters can be written for different operating systems and can be run without any or very little change to the source code. Python follows very much the same type of scheme in that there are interpreters for Linux, there are interpreters for macOS, there are interpreters for Windows, and you don't have to change your source code in order to be able to operate on any of those. So in this example, I've launched a Python shell, and after installing inside of Windows, you get a Python 2.7, and you get the Python GUI, which is idle, which gives you this. Over here on the right-hand side, I have a Python tutorial, and I am using version 2.7. So what I'm going to run through here is the tenets of how to operate things inside of Python. And first off, we're going to start with numbers. Now, numbers to computers or at least to Python, is noted in two different formats. It's noted in what's called an integer format, which is a whole number, and then it's noted also in a decimal format, which are called floating numbers. So one of the key things to note about Python, at least in 2.7, is that performing operations with whole numbers will always give you whole numbers. In order to make a floating point number, you at least have to make one of the operations a floating number. Case in point, here I took 7 divided by 3, which in the real world is 5 2/3. And just using integers, I got the integer portion. Whenever I turn one of those into a floating point number, I get the floating point returned. So you can always force a integer by using a double division. That forces it to be, it gives you a floating point number, but it does basically only the integer part of the system. And likewise, you can do the remainder with what's called the modulo, or the percent sign, which in this case would be 2, because the remainder of the division here is 2/3, so 2 1/3. Really handy if you want to start breaking out programs by integers and fractions and things like that, but sometimes it's really useful to use the modulo whenever you're iterating through a loop or doing something else like that. So the other thing to note, arithmetic in Python, it follows the algebra orders of operation. So case in point, the multiplication and division are performed first before the addition. So if it's 5 plus 3 times 2, we get 11, because it's 6 plus 5, not 8 times 2. And likewise, we can do exponents. With the double asterisk. So asterisk by itself is the multiplication, however double asterisk is exponents. So now that we've kind of covered numbers and being able to do that, one of the major tenets of programming is the ability to use variables. A variable is simply a name that you assign a value into, and the value can be a number, or it can be a string, it can be any data type, and they're commonly used in order to be able to store something that you can call then with the word later. So in this instance, we're assigning the integer 20 to the variable called width, and you'll note that we're using the equal sign. And likewise, we're going to assign height the result of an arithmetic operation. So because you have to have a value or a data type go into a variable, Python will interpret this before it assigns anything. So if I say give me height, it didn't store that, it stores that. And actually, if you want to really get technical about it, Python isn't really saying I'm creating a variable with the name of width inside of it and then putting that in there. It does something. It does a placeholder in memory where it calls this and this and creates the connection between the two, but it's kind of one of those aside things. In addition to integers and floating numbers, there are built-in support for complex numbers, imaginary numbers. There are some options for decimals and fractions, which are different data types that can be looked up dynamically inside of the Python documentation, as you note that there are hot links. So in addition to numbers, variables can also be given strings. Now, strings are handled differently inside of Python. And in this example, what we're going to see is they can be enclosed in single quotes and double quotes. And if you need to use like the single quote inside the other quote, you can use a backslash to essentially say, I want this to be a literal. So for like doesn't, DOS, you notice that the color changed for T because that is also designating this part of the string. However, if we put a backslash in there, then it creates, well, I didn't end it, did I? So I gotta do DOESEN backslash apostrophe T there. I forgot my ending quote in order to close that out. It basically turns that into a string with the quote inside of it. Now, if you want the whole thing to be able to use special characters, like for example, since the backslash is a special character indentation, Windows pathing also uses backslash. You can use an R right in front of your opening quote in order to have the backslash interpreted raw as a part of a string. There's also multiple line quotes, which can be specified with triple. Multiple line quote. So triple to start, triple to end. And although this is, I hit an enter in here. This is special to note that the special character in an N is shorthand notation for next line. Also, there are some amount of use of the arithmetic operations with strings. In that plus concatenates and the multiplication or the star or asterisk repeats 3 times. So concatenation and repeating, you basically take how many times you want to repeat and go from there. Now, there's an implied concatenation if you're using literals right next to each other, but it only works with literals. You can't do that inside of a variable. So for example, I'm going to assign variables. Item 2 equals item 2. Now if I do literal item 1 and literal item 2, I get them concatenated together. But if I just type item 1, item 2, which are my variables, then I can't do that. However, I can go ahead and do an explicit concatenation to perform the same function. Then that's useful to know in that the same concatenation and repeating that we can do with strings, we can also do with variables that happen to be assigned to strings. Strings, Python has the ability to also treat strings as an index, in that you can pick specific sections of the word or the string that's assigned to it. So if I were to call item 1, but I want position 1, then I get the T. Now the question becomes, I asked for the first item 1, or the first index in the string item 1, which gave me the second character. That's because the indexing starts from the 0 position. So for example, if we wrote a text string like this, actually let's do that. Let's do it in text. So we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, ITE, and 1. So that's the content of our string. So we see how this maps out. True enough, the the index of 1 corresponds with the letter T, just like the index of 4 corresponds with 1. So let's see if that holds true. We go item 1, position 4, and we get the string of 1. Yep. So just know that whenever you're talking about indices, it starts with 0. And this is important to note because it can be handled programmatically. If you're running through a loop and you're counting and you're wanting to look at specific numbers, you'll have to basically, if you're counting ordinally from 1, you'll just have to decrease your count by 1. So if I'm on the second iteration of the loop, I just have to subtract it by 1 to get the second item in the string. So, and there are ways to span, basically to get sections of the word, or also called slicing, and it's done by using the colon. So you specify numbers on either side of the colon to indicate a starting and ending position, and likewise if you eliminate the starting or ending position, it assumes either the front or the end respectively. So for example, in this instance, if the word is Python and we do a :2, it says I want the beginning up to the second item. So this is important to know that even though technically it's starting with the second position, so this is the second ordinal, which let's do PYTH, PHYT. If I could type. So in this example, a word from 0 to 2 just returns this portion. And the reason for that is that whenever you're talking about the ending and you give a ending number, the slicing goes up to that number. The end is always excluded, as noted here. And likewise, we're talking about going left to right. You can reverse it in that as it states here, we have 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, right? And you can start counting from the opposite direction with minus numbers. Let's see. Specifying a specific slice number that is not in the string, so like the 42nd slice, you're going to get an error. However, if you specify an ending as a part of slicing, it simply returns as much as it can interpret. So while whenever you look at strings in using the indexes, it looks like that you might be able to assign or change certain things in the string by saying, I'm going to give you the ordinal number and I'm going to give you something new to assign it to. Strings can't be changed like that. They're called immutable strings. You simply have to create a new string on top of it. And in this instance, it would simply state, use the slicing in order to cut out the portion you want to replace. And at the very end of strings, we're also going to get into what is called a built-in function. There are certain words within programming languages that are automatically called inside of the programming language to return something. One of those happens to be length. So in length is a built-in function that you give in an object and it returns the length of that object in an integer format. So the length of item 1 is 5. Yes, correct. So one of the nice things about the interpreter is the fact that it will give you, upon typing a built-in function, it will actually give you some of that coding string of object returns a string. Likewise, I can do so int is a built-in function, as well as float is a built-in function to turn something into a floating number. And it's noting, the interpreter is noting functions in there. One key point about built-in functions is that you cannot name a variable the same as a built-in function. So calling a variable float or a variable len is not allowed. I'm not going to do too much with Unicode strings. The next data type we're going to talk about is called a list, which in other programming languages is simply an array. Arrays are collections of different items, like this example, it's doing squares. So 1 squared, 2 squared, 3 squared, 4 squared. And it creates a list type of data structure. Likewise, lists can have sequences, just like strings do. However, one key point of lists is, unlike strings, lists can be changed because they're individual items inside of the list. So you can take an individual item inside of the list and then specifically replace it. Lists support concatenation. Lists support a method. So a method is a programming term for a function that is built in on an object. And here, case in point, we're creating a variable called cubes, which I'm going to paste into here, and it doesn't like my indentation, so I'll do that. Oops, and I didn't close it off. Let's try this again. And this time I can, oop. There we go. Now we can, cubes is a variable that is a list type containing that. To call methods, hey, look, our IDE does different things. These are the methods I can do on a list: append, count, extend, index, insert, pop, remove, reverse, and sort. So where that comes into play is, rather than give a function on a list type and then have it equal something, I can simply call a method, hand it what I want to add, and don't have to do anything extra. It's more or less a shortcut. Let's see. You can nest list. You can have two-dimensional lists. This talks about how you can reassign slices, including completely clearing lists assigned to variables. Remember I said in slicing, if you omit a starting or an ending number, it assumes the front and beginning respectively. So this is being interpreted as replace letters from the front to beginning with a completely blank list. So just know that that's using existing rules about slicing in order to be able to replace something. You can call indexes three-dimensionally or two-dimensionally with a multi-dimension. And now that we've called all of that, we're actually going to get into some programming. So in this first program on the Python tutorial, we're actually going to get into Fibonacci sequencing. So let's do this. I'm going to do something I hadn't done before here either. I can assign multiple variables in a pseudo list format. I'm not surrounding these with brackets, but I'm saying A is going to get that value, and B, after the comma, is going to get that value. And then now we're going to introduce a loop. Comma B equals B, comma A plus B. So let's walk through this logic. We've assigned 0 and 1, and to kind of show you, because there's no open type of input on here, sometimes it's easier editing script in in a text editor before you throw it into the interpreter. So let's walk through this little mini program. We are assigning variables: A, an integer of 0, B, an integer of 1, and then we're issuing a loop command called while. So what while is it says, I'm going to give you a condition, and then I want you to loop while that condition is true. So to start, we're assigning B equal to 1. So the while loop starts and it says, for me to run, B has got to be less than 10, which it is. So it's 1. So what do you want me to do? The start of the loop begins after our colon. That indicates that this is a looping command. And then other programming languages have you use curly brackets. Python instead uses indentation to indicate loops. You'll note that whenever I was typing this in manually, the only thing I did after this was press return in order to get the program to run. And we're going to do somewhat of the same thing whenever I copy this. So here's what I'm going to do. I'm going to paste this. And I don't think I did my indentation right. I didn't. Okay, there we go. Let's see. Let's write A plus a space plus B, and then we're going to assign A, reassign A and B to be A plus B. And I should have used a comma. A, B, 1, while B is less than 10, print A, comma, B, A and B get reassigned to B, and A plus B. There we go. Okay, that did what I wanted to. So, in this column we have, first column we have A, in this next column we have B. So after while gets evaluated, it prints my two numbers. So you know we're starting with our two numbers here. And then it does another arithmetic reassignment. It's assigning A what B was, which we see here. This is B, now assigned to A. And then it's adding A plus B. Now it's doing this concurrently. So rather than I'm assigning A to B and then I'm assigning B to A plus B, it interprets, because these are being done at the same time, it interprets A plus B to be what the previous A plus B is. So 0 plus 1 is 1. So that's why we get that added up to that. That added up to that. That added up to that. So it's important to note, now if we had separated those into individual statements where we said A equals B, then we have effectively changed A, and on the next line if we did B equals A plus B, then we'd get a skewed number based on what we want to do here. But by declaring the assignment on the same line, we're getting to run concurrently. And we note that because we entered a enter after the print statement, this is separating. So let's do this again, right? And let's instead do a while B is less than 1,000. We're going to print the result and then not end it. So there you go, the Fibonacci numbers in sequence. In that comma at the end, comma being a add-on, does not insert the new line at the very end. I'm going to go to more flow control tools in the next video, and that will summarize it for part 1.